Hello everyone, this is Thara Prabhakaran from Indian Institute of Tropical Meteorology, Pune. I like to talk to you about the monsoons and cloud microphysics campaigns. So let us see what is let us see what is Indian Institute of Tropical Meteorology, my institute. Actually, we mainly understand and study the monsoons at various scales from climate to the minute scales, and we have a major program named Mission Mawsum. Under this program, we are establishing observational networks. We are studying monsoon from the various scales of forecasting, developing models for high impact weather, as well as for the atmospheric chemistry and air quality forecasting. And we have also a weather modification program and um, capacity development program, and as well as the frontier observational capabilities development program. And ultimate aim is to have a weather ready nation, and we are also interested in collaborating with the other institutions and nations to make and work together to protect people and livelihoods. So this is the concept of Mission Mausam. It is executed by our Ministry of Earth Sciences, Government of India, and our institute is under this ministry. So let me come to the point of my discussion. Actually, what you see here is the global regional monsoon domains. In This is a picture taken from the IPCC AR6, and I have noted a number of field campaigns conducted with the aircraft and other uh, ways to document the clouds, precipitation, and or also aerosols, few of these campaigns are also involving chemistry. So as you see here, there is a significant, actually less number of campaigns conducted in this region, especially in India and also in African region. And my focus is to tell you some of the campaigns that I found in the literature, as well as the campaigns that we are doing in India. Um, Currently, I am the project director for this program called CAIPEEX, which is the Cloud Aerosol Interaction and Precipitation Enhancement Experiment, which has been going on for more than a decade now. And we have specific objectives under that program. I will tell you on that. And when we look at the history over this region, one experiment called MONEX, which was conducted over the seas around India, and there are some very legacy papers from those campaigns. This is actually some of the observations for the cloud microphysics in the Bay of Bengal in a depression, and that is it was published in 1984. So uh, it just looking at since then there were very few campaigns only, and our program, the Skypex, it is to undertake fundamental studies on aerosol cloud and precipitation interactions, as well as to develop strategies for weather modification. So you can indeed have a look at this paper that we have published in BAMS to get an overall idea about this program. I just want to show you one example of what we found during the monsoons. See, when we compare with the previous campaign, Indo-X campaign over the Arabian Sea, which was looking at the polluted clouds over the Arabian Sea, and So what you see here is the aerosol number concentration measured in the boundary layer, as well as the cloud droplet number concentration. This, when I say the boundary layer, it is just below the cloud base. And so the observations are shown from different parts of the world, different seas, as well as from the CAIPEEX. You can see that the droplet number concentration has enhanced um, in in the case of CAIPEEX, because this is the only continental observations that are available here, and these are corresponding to many aerosol polluted clouds. So, moving on, I also want to show you the vertical structure of these kind of clouds. See, as here I'm showing the vertical variation of the cloud droplet number concentration measured in some of these clouds during a pre-monsoon conditions. This the leftmost figure, the pre-monsoon and the transition and a monsoon. What you see on the with the symbols, it is actually the droplet effective radius. Size of the symbol indicate the droplet effective radius, and the color indicates the liquid water content. So it is seen that the in the pre-monsoon conditions, the cloud base is at a higher altitude, and in the monsoon, cloud bases come down as we have more moisture in the subcloud layers. And also the liquid water content actually attains maximum value at a higher altitude. So this dash line is the freezing level. And also the layer that is having this warm layer, actually in the pre-monsoon condition, it is less deep compared to the monsoon conditions. These are very important to decide the kind of cloud microphysics that is seen in these clouds with the monsoons. And so we have indeed investigated these kind of observations over in very different contexts. These are pertaining to convective clouds, and so I want to also take you to this is the drop in the cloud base height, and I want to take you to some of the observations also from African continent, that is from the DACCIAWA campaign, which was conducted in West Africa. And aerosol impact on the low level clouds over the West Africa was investigated in this Taylor et al. 2019 study. You see that the range of droplet number concentrations found are nearly the same. Um, and this is the vertical variation in up to 3 kilometers. And also for different offshore and inland locations. And the one interesting aspect is that offshore locations showed the less number of droplet number concentrations, as well as the pollution. This is indicative of the accumulation mode aerosols that are going to become cloud droplets, and that is also quite less over the offshore regions. And the effective radius, however, showed a slight enhancement compared to the inland locations. So um, it has been noticed that the biomass burning aerosols transported from the southern hemisphere had an impact there, and the also the urban and the local urban aerosols indeed contributed to some of these enhancement in the cloud droplet number concentration, but locally, but there is a negligible impact in the regional perspective. And this campaign was conducted in 2016. So again, this was also looked in a different throughout the campaign period. It was seen that the inland location had a higher aerosol number constant and accumulated mode aerosols, as well as the droplet number concentrations were high in those regions compared to the offshore regions. So the one interesting aspect was noted offshore and inland clouds had similar droplet effective radius in certain situations and the higher droplet number concentrations. So thus, there is higher liquid water content in those clouds. So now, also this was also seen in the impact was seen in the size distributions of the aerosol particles, as the local emissions had majorly. This is actually for the offshore conditions, more cleaner conditions, and the local emissions indeed had a fine mode aerosol particles compared to the inland locations where we could see that there is more accumulation mode aerosol particles, and this has indeed contributed to the enhancement in the um, droplet number concentrations. So I just want to say that this data, actually there may be still more explorations to be done for this data, and probably together with the other monsoon regions and monsoon campaigns, and I just have seen these some of these publications that will be of relevance, and so I thought maybe to introduce this to the attendees here. And also, I also want to say that there is requirement of more field campaigns in this region to understand how the monsoons and um, the cloud microphysics or the dynamics are behaving in this region. So that is one thing to mention, and also I also want to mention about this International Commission on Tropical Meteorology, which was formed just last year. This is a commission under the IAMAS and IUGG, and there are over 25 experts from different organizations worldwide, and ICTM indeed a commission conducts and organizes meetings on tropical meteorology and works on advances in various topics in tropical meteorology. So this is just the proposed objectives of the ICTM, which was approved, and we are hoping that we could work with more regional scientists from who are working on these topics. And with this, I want to thank you.